Okay, so quick demonstration of ilk long, and we will develop a few HTTP endpoints and model them. So the point of ilk is to ensure data consistency and describe the what and not the how. So we will just see how it works. So we can imagine that we can describe three endpoints, something like post users to create our user. We can get, say, me to get our user, and maybe something like put user's name, something like that. So it will the username. So first of all, we'll declare the types. So there are three levels. The two most important ones are the types and the instances, and it doesn't really work like what you might expect. So maybe I should find other names. But basically, the types here are shapes, and they will describe constraints. And the instances will be what we usually call types. And the third level is what I call refinements, and it will be the single level with concrete values. So we declare a type endpoint, and I think I should. And for now it does nothing. I can save. Okay, so you've got the compiler output here, and I will describe my first endpoint. So I say create user. Okay, it's just the coloring that is broken. Okay, so our endpoint has a method that can be something like get, or we say post, or put, and then when we describe that, we can say method, let's say get. And the type checking passes. If I do something like that, it won't work. So we also have a pass, so we say that it will be a post, and the pass we say it will be users. And currently I don't have a pass defined, so I can say, okay, the pass in one of my endpoints will be a concrete string, which means the instance must pick a string value. We have broader types. If I just put a pass of type string, it will mean that the endpoint must accept any string, if you see the difference. So our pass is a concrete string, and let's say I want to create my users. So maybe we'll do something like with the ID generated, and it will return, so we can describe the responses, and a response will be something like with a status, which is an int, and it's a mandatory field. I mean, like method and path, because it doesn't make much sense to have a response without an HTTP status. But as you can see, if I do that, you can see that the record field, all fields in the types, all fields are optional, except if we put the exclamation mark. In the instances, it's the opposite. All fields are required, except if we pass an optional question mark. So we can now describe our response, and it can be something like that status, and here you see I did a mistake because let's say, okay, created. This one should be a concrete int. And let's say we have put that there. We have a body that can be anything, and our body will be something like, will contain ID, which is a UUID. Okay, so now we don't have the contract is very broad because we didn't say anything about where this value comes from. So maybe something easy, just for illustration, is that we can say, okay, there will be also something like an authentication header, and for this endpoint, the auth header will contain something like user ID, which is a UID, and now I can say that the source of the data for this is out. And now you can see that no source found for field ID, because there's a automatic resolution if it's the same name, but if it's not, we have to be explicit about the mapping. So I can say, okay, this one is user ID. If I say this one, I can change the type checking, so we can say that, okay, the type not work, and there's also I think there's also optionality check, which is a mandatory field. We describe this one as mandatory. If I wanted to say, okay, maybe I can return an ID, I will do that. So a mandatory field can't rely on an optional one, which is basically what you expect with your data. So this is very simple. We can model things that are a bit more complex. Maybe we can say, okay, typically my endpoint, the create user will write to a database. So you might want to model that. So it will introduce a bit more advanced features of ILK. So I can say, for instance, that our endpoint also has a query, and it will be our database query. And let's say, okay, our query will have some parameters, which will be basically the method. So we can say, okay, func name should be a concrete string. We've got parameters, and we have the return of our function. So now I can say, okay, the query will be, okay, maybe I can set that as required. Can we have, yeah, we can have something without parameters and without return. So func name will be something like create user. The parameters it takes will be the user ID, which will be a UUID, and it will, or maybe it just takes nothing, and it will take nothing here, but it will return the UUID, and here we can say, okay, as the source, the data sources, we can say, okay, query.return will be accepted. So this will be query return and user ID, and it's good. So yes, it can be as simple as that. Maybe we can try, we will refine afterwards, the update name. So we say it was a put on user's name, and we can say, okay, an endpoint takes also parameters, which can be anything. And here in the, not here, but here, we can say, okay, it will take the name that is any string, and our function will be update user name. It will return nothing, but take as parameter the name and the ID, which is UUID, and then return something like that with the body. But now we can wonder where this come from, so I will just refine our query and say that it can, the source of the data here will be params or out. And by doing so, you can see that the ID and the user ID are failing. So this one is strange because we will return the user ID, and so we have to mark that as an output field. So it doesn't, so there's no issue anymore there. And last question, where does this ID comes from? So we can say, okay, this one will be from authentication, and there will be a user ID, something, which is a user ID, and there we can say, okay, it comes from out user ID. Okay, and this pass. And now maybe you want to go even deeper and say, okay, but I've got my database tables, and how can I ensure that it's meaningful? Because currently we didn't describe anything about the database except I mean the interface maybe. So for that we can maybe create a new type that we will call table schema, which will represent a single table. And what we can do is, so maybe first I will extract this and db query. It will be easier. Type db query equals this. And now what I can do is I can create an association between types. So I can say my type dbQuery is associated with one or several table schemas. And what I can do there is define an instance of the table. So I can say, okay, user table is a table schema, and now we'll describe what what are our columns. So we can say, okay, there's an ID and there's a name. Now I can say, okay, this one is associated with user table. Associated and pointer, what's the issue? Table schema not allowed, expecting web. This, okay, it's not the endpoint. It's not the endpoint, it's the query. Sorry. And inline association, that's new. And this one is also will be associated with the user table. And now what I can do is update that and say that maybe for instance we can describe maybe an update. So first of all, the source of the return, I mean, it will be, it can be two things, but it will be our associated type. Now there's an issue, no source for user ID, because in our table it's not user ID, it's ID. So then I can solve that saying, okay, this comes from special syntax for association. You have to start with a dollar association user table dot ID, and it should be okay. Yeah, the validation passed. And so this one is okay. And now for the update, maybe we can create a special function, something like update, that will take a list of table schema and have as source the parameters and the associated schema. And we'll see why there, because I can say, okay, create user params, and now I can describe that our update will be something like, we'll update table schema and say, okay, the name will be a string, and it comes from the params. What did I do wrong? Yeah, it's not a table schema, it's the user table. We should reference the instance itself, and we can say okay. And now we have this thing. Okay, so this is why I say, okay, the source can come from the association, because there the compiler will check, okay, do I have any enough information for all the fields? And there I can, because I added the fact that user table ID. Okay, this is okay. And typically for let's say an insert operation, I won't allow to get data from the existing row, because if you insert, you've got nothing. And then here I can describe the insert that will look basically the same. It's the user table. And now we'll see, okay, where the name comes from. Because we say, okay, we insert a user, there's no name anywhere. So where does it come from? So we'll do something like that. Say, okay, in our parameters of the HTTP endpoint, we'll need a name. And then we have to do the explicit mapping, I think. Params not found. Okay, so as you can see, the name issue is gone, and now it asks, okay, but where the ID comes from. So there we can say something like that. The ID will be a UUID, and because I had a star at the end, I mean it will be generated. And now I've described my two endpoints quite quickly. I don't know how many time I spent on that, but and the idea will be that once it type checks, there's a JSON backend that needs improvement, but there's a JSON backend that can output the data model, and then you can feed it to other tools.